Alright everybody, today we're going to be doing lesson 32-1, Scatterplots, in your textbook. It's on page 445. Please get out your textbook, take some notes in there while we're working. Today we're going to be talking about scatterplots. And to do it, we're going to find a statistical sample. In this example, the population we're looking at, sorry you can't see it, it's off the screen, but in your book you can see that it's crackers. So she has a question about crackers, she's interested in crackers, so she's going to do a statistical study on crackers. So she goes to the grocery store, she wants a random sample. To get a random sample, she takes a whole bunch of, and she's at a large grocery store, she takes a whole bunch of crackers, that's her population, all brands of crackers, and she puts them all in a cart and mixes them up and closes her eyes and pulls out 9 packages of crackers. So she's trying to be random by putting all the crackers in the cart, mixing them up and pulling out 9. And that's not too bad. She doesn't pick 2 variables though, she picks 4 variables. She's got fat, sodium, fiber, and the total number of carbs. These are all numbers. So we would say this is numerical data. There it is, sodium, fiber, total carbs, numerical data. Because the answer to all those questions is a number. And then she's also checking which ones are whole wheat and which ones are not. So whole wheat and not whole wheat, we would call that categorical data. So it's still a variable, but it's not going to be a number. Other examples of categorical data might be color, or shape, or maybe your grade level, whether you're a freshman or a sophomore or a junior or a senior. So categorical data is going to put your population into a category, but we are going to be mostly dealing with numerical data. All right, so in order to do a study looking for association, we're going to pick just 2 of these variables. I got a lot of choices here. We're only going to do 2 at a time. It's hard when we look at the table to try and figure out if there is any association between these different numbers. Do they have anything to do with each other? Let's make a scatter plot and find out. So on the very next page, page 446, we've got a place where we can make some scatter plots ourselves. So the first scatter plot, we're looking for an association, which is the degree to which 2 variables are related, generally described in terms of direction, form, and strength. We'll talk about direction, form, and strength more in the next lesson. All right, so our scatter plot is going to be total fat versus carbohydrates. So on the x-axis, we're going to plot total fat, and on the y-axis, we're going to plot carbohydrates. That's just a random placement. I don't know that fat causes carbohydrates. It's hard to do independent-dependent with statistics because we don't know there's a relationship. We're trying to figure out if there's a relationship here. So I don't know what I'm talking about right now. Come on, Mrs. Thomas, let's plot this data. Okay, here we go. Oh, one thing I wanted to point out was this break in the y-axis. So the y-axis is broken. It doesn't start at 0. It starts at 15, and that's why they put that squiggle in there. You may not do that in algebra. Please don't ever put a squiggle in your graphs in algebra. It really messes up your y-intercept. But if you're making a scatter plot, it's fine. In fact, it's very helpful because it's like zooming in on our data. It's going to make it easier to see if there's any association between these two variables. So we are going to go ahead and plot our data. All right, I've sped myself up here. Go ahead and pause the video and try plotting it yourself, and then you can compare what you got to what I got. So zaps were whole wheat. And waves of wheat, that was 4. And super grain, that was 323. And that's it. All right. What do you notice? Do you notice anything? So the association we're looking for is, as one variable is increasing, can I see a pattern to what's happening to the other variable? What do you think? Do you see a pattern here? Is something going on? I would say in general, and this is not linear, right? And it's not a function. All these points are right above each other. This is a scatter plot. And scatter plots are really well named because they look like a scatter of points, right? Some are more scattered than others. But we do end up with a scattering of points because each point represents a different member of your population. These are all different boxes of crackers. So we would not expect a nice line like we have when we're paying $10 per hour for something. That's not this. In statistics, we gather data. We gather 2 variables from each member of our population, and then we graph them, and then we look for any sort of association. Now, as the fat is increasing, as we go from a fat of 3 to 4 to 5, in general, the amount of carbs is decreasing. Do you see that? So here, the low-fat crackers tend to have really high carbs. All of these low-fat crackers are way up there in carbs. And then these high-fat crackers all have lower carbs, and we've got some that are in between. So this is actually, for a scatter plot, this is a very clear association. I would feel very comfortable saying that as the fat content increases, the amount of carbs decrease. You guys got that? So the association is that as the fat increases, the carbs decrease. And then we can do something called a best fit line. So this line would definitely have a negative slope. Agreed? This, I don't know if this is linear or not, but I can try a best fit line to see if it makes sense. So when I'm drawing a best fit line, of course I'm going to use a ruler. Don't be silly. And I'm trying to find a line that goes through the middle of the data. I'm not trying to connect points. This is not dot to dot. I'm going to draw a nice straight line, and I'd like it to be in the middle of the data. I'd like to have about the same number of points above the line as I have below the line. And I'm not going to worry about actually going through any of these points. It is fine if your best fit line does not actually go through any of your points, as long as the line goes through the middle of your data. Okay? So that's a decent best fit line. Maybe it should have been a little lower here. But the line helps us more easily see the association. These points actually do kind of follow this line. It doesn't look like they're curved to me. So I do feel like this is a fair line. It's not super obvious, but there's definitely something going on here. Okay? If there was no association between fat and carbs, I'd have a scatter plot that was truly random. Dots up, dots down, dots to the right, dots to the left. No association at all. You guys got that? Let's do the next one. So now we're looking at the association between carbohydrates and sodium. So let's plot those. Again, now they have broken both axes. They're starting at 15 instead of 0 for the number of carbs. And they're starting at 150 instead of 0 for the amount of sodium. And what that's going to do is it's going to zoom in on our data. If we started from 0 and had to go all the way up to 500, our graph would be enormous and all of our data would be all clustered in a tiny little point. So by breaking the axes, we're spreading the data out and making it easier to see. All right. Okay, so I've plotted all my points, and I'm looking for an association. Excuse me. These points are pretty spread out. It's hard for me to see an association. If I kind of try and convince myself, I could say, as the carbs are increasing, the total sodium is also increasing, because here, these boxes of crackers are low carb and they're also pretty low sodium. And then up here, this box is high carb and very high sodium. You should not eat these. These probably aren't good for you. But if I erase that point, then I lose my argument. And your whole association shouldn't be based on one point. Now that you see this scatter plot, you probably think this scatter plot looks pretty darn clear, right? These points are clustered pretty close to this line. It makes this line look like, yeah, that's the trend of that data. While this one, I'd have a hard time drawing a line through. I'm not even sure I would want to. So here we definitely have an association between fat and carbs, and here, not so much.